let's look at the cases with the current sources in the circuit. The main issue with the current source because we're trying to write the KVL equation for the mesh current analysis, but you do not know the voltage across each current source. Could be anything, right? That's an unknown. So therefore, you cannot use that to solve the circuit. So we'll see how to deal with this. There will be three different cases. Case number one is if the current source is in parallel with some impedance, and in that case, we can do the source transformation, turn that into a voltage source in series with that impedance, right? So since this voltage source is, then we fall back into the basic case, and so we can write the equations by inspection. And the second case is if the current source is not in parallel with the impedance, and also it's not shared by the two meshes, and in that case, that current source would be equal to the mesh current in that mesh, or negative mesh current depending on how their orientations, right? And the third case is if the current source not in series, not in parallel with any impedance, also shared by two meshes. In that case, we need to use a so-called super mesh, so we can write the KVL equations for the two meshes that are sharing the current source. Okay, so let's look at the examples as I did for the node voltage analysis. I'm not going to go all the way to the final, the collective term, things like that, or form the matrix form, the similar step you had for the basic case when in those steps. So otherwise the video would just take too long. So in this case, let's start with the first. This is the first case. The first case, we have a current source. You recognize this is a current source, right? I hope you do. And this is a current source. This is in parallel with this resistance. So we can do the source transformation on this one here, and we can write this. We can turn that into a voltage source in series with that impedance. And this voltage source that should be the current source 2 over S times 4. That should be equal 8 over S. Okay. And pay attention to the orientation of the polarity of the voltage source. Okay. The plus on the left and the minus on the right. So if you put the minus on the left, so in that case you need to put a negative sign, right? So we are not gonna make our life too difficult, so I'm following this. So we basically need to replace this. I'm not gonna redraw this circuit. Hopefully that's okay. So let's write the node voltage equation by inspection. Now I only have voltage sources, right? So in that case, in mesh number 3, so this is the place I'm gonna replace this, right? Replace by this. So let's see if we can write the node voltage equation, the mesh current equations. Remember let me maybe start here. So I get a little bit more space here. And so in this case, on the diagonal elements, those are the impedances, the sum of the impedances, right? So in mesh 1, we still have 5 over S plus 3 plus 2 off diagonal elements that's shared by the meshes, and -1, -2, and -3. So this 1, 2, so shared by mesh 1 and mesh 2, and 1, 3 position that's shared by mesh 1 and mesh 3, that's -3, right? And for the mesh number 2, we have 2 elements. By the way, they are symmetric, right? So we have 2 plus 3s, and between mesh 2 and mesh 3, that's a negative 3s, right? For, in this case, we got a negative 3 here. That's shared by, the impedance is shared by mesh 1 and mesh 3. And mesh 2 and mesh 3, that's a negative 2. That's a negative 3s. Because this should be symmetric. And for mesh 3, we have 3. So the impedance plus 3s plus 4, right? And in this case, I have I1, I2, I3 as unknowns. And we have the voltage rises for each mesh. So for the mesh number 1, we don't have anything, we have 0, right? For mesh number 2, we have the negative 12 over s. For mesh number 3, remember we choose this direction. So for this one here, the sources we have here, this is the voltage drop, 8 over s. So we need to put negative sign also for mesh number 3, negative of 8 over s. Okay, so that's for the case number 1. For case number 2 is if we have the mesh current that's not shared by any two meshes. In this case, this is a current source that's actually creating the trouble, right? That creates the trouble. So let's do the, I don't think mesh 1 and mesh 2 and any difference. So mesh number 1, let's see, we still have, now I'm writing the basic equation. I'm not doing the by inspection because now we have the current source. And so in this case, I still have 5 over s times I1 and plus I3 times I1 minus I3 and plus 2 I1 minus I2 and that's equal to 0. And mesh number 2, and still we are choosing the same reference direction for the mesh current. And so in this case we have a 2 times I2 minus I1 plus 3s times I2s minus I3, and that's equal negative 12 over s, right? For number 3, mesh number 3, and in this case we don't really have any KCL equation to write, and instead we're going to use the element constraint and the element current and also the node current relationship, so that in this case I3 is going to be equal to negative 2 over s, because this one is going this direction, the I3, right? So the current is, for the source, is going the opposite direction, so that therefore they are we have a negative sign here. And let's look at another case. Let's see if we have two current sources, if we have two meshes sharing the same current source. By the way, this is a current source, right? And in this case, we are trying to write the KCL equation. In this case, we're gonna form a kind of so-called a super node. So we're gonna write the KVL equation around this bigger mesh, and so that what we call the super mesh. For super mesh, for the super mesh, we can write the voltage across each element, the drops, right? The drop of the non-source elements. And let's start with the 5 over s again. 5 over s times I1 and plus the 3 ohm across the 3 ohm, the voltage drop, and that's I1 minus I2 times 3. I1 minus minus I3. And for the 3s, so we are adding this one here also, right? So this voltage here is 3s times I2 minus I3. and that's equal to the voltage rises, and in this case we have a negative 12 over S, right? And also we know the mesh current I1 and I2 related to each other by I1 S minus I2S is equal 2 over S, equal this current, because the orientation, so the net current I1 minus I2 is equal to this current. If you're not sure about this, go back to the lecture on the phasors, and in that case I had a detailed explanation of that. Okay. And for node number 3, for mesh number 3, this still the equation we had before, right? Nothing changed in this case. So that we had, let's start with the 3 ohm. So 3 ohm I3 minus I1 and plus 2 ohm, 2 times I3 and minus plus 3S of I3 minus I2. That's equal to 0. So these are 3 equations we can write. 3 mesh current equations we can write for the mesh current analysis. In this case, we have the current source. The super mesh, super node appears to be more difficult. Nothing really difficult, right? It's just you still following the KCL and KVL, right? The equations, and that's about it. So let's look at the last cases. What are we gonna do if we have the dependent sources?